Hello, everybody, and welcome to the second meeting of the Cluster API Node Bootstrapping Working Group of the CNCF Cluster API project. We adhere to the CNCF Code of Conduct in this meeting. Please don't talk over each other. It's fine to just talk because we're a small circle. If it gets too heated, we'll just use the please raise your hands feature, but it worked pretty well last time around. And please be nice and considerate to each other. And having said that, I think we can start the meeting. Before we go into our regular agenda, does anyone want to introduce themselves or say hi? All good? Cool. All right. Let's get started. All right. First agenda point is the check-in and have a look at the current dones and to-dos. We don't have any open to-dos. The work on the second work stream or track split kubeadm into kubeadm Cloud Init and kubeadm Ignition. That work has started. That was a to-do for basically all of us. Johannan is spearheading that, and he came up with the implementation notes. I would, for the time being, remove the first work stream, like the whole architecture bootstrap separation from this from the agenda, so we can focus on the second. And we have the implementation notes. Great work, Johannan. And I guess that'll be the main focus of this meeting. The second to-do that we had and which is done was having a calendar entry for this meeting, which I've created. It's linked in the PR for the markdown for the working group, and it's also linked in the working group meeting minutes. There's an iCal link as well, which you can import into your favorite calendar tool, so you're not forgetting about this meeting ever. And I scheduled it 1 hour too late. Fortunately, no one looked at the calendar, so everybody's here. And I just fixed that, so very good there as well. Which brings me to
Do you
the...
mind?
Come again?
Sorry, do you mind posting the link to the agenda doc in the chat?
To which of the two? To the working group or the big one?
The chat, the Zoom chat.
The Zoom chat. Okay, yeah, that's fine. So everybody can see what I'm looking at. If I find the chat button here it is. All right, just link. Sorry, I should have done this from the start. All right.
Okay. Let me also share the tiny implementation notes document that I just started a couple of minutes ago. There is a lot of info there, but people can follow that too.
Absolutely.
If we talk about the technical details, yeah.
It's already in the agenda doc in the second work stream. It's probably more handy if it's in the chat. Thank you. There's one little item which, before I forget it, wanna check off in the beginning, and that is our first meeting in January. In that week, I'll still be on vacation, and I'll be literally offline, like camping at the Baltic Sea, and there's hardly any internet there. So if you folks want to have that meeting on the 2nd of January, you can absolutely do it. If you don't want to have it, we say now that we cancel it, and then I remove the occurrence from the calendar, and we're good.
I will be out.
Perfect. Okay. Let's cancel it then. Give everybody their vacation, and that's all I had. Giving the word to Johanna.
Sure. Yeah, given that I suspect I might be the only person not celebrating Christmas around, maybe I can just spend that time implementing if we get to some agreements regarding regarding the tasks. But yeah, I also didn't want, I mean, I started the implementation document, but I didn't want to start coding and like hogging all the tasks to myself before we coordinate and agree on who does what. So yeah, current state is we're looking into separating the low-level ignition code that we have and Cloud Init code and kubeadm related code that we have all currently bundled up inside CABPK. The current state, as far as I can tell, is that, I mean, the main problem that we have is that the ignition package, which is Bootstrap kubeadm internal ignition with slashes, it depends on Cloud Init. And by depends, I mean it literally imports Cloud Init and basically uses all the base types from the Cloud Init package in order to do its thing. Now, both of these packages, the main thing that they do is they take some structs, populated structs from above meaning the kubeadm config controller. They read the values there, they interpolate the values and render into a Go template and render a string as a slice of characters that are basically just the config that can be passed to machines. Now, if we wanted to separate, I can also open my IDE and show stuff if that's helpful. Please tell me if that's necessary, but for now I'm just talking theoretically. If we wanted to separate Cloud Init from Ignition, so I'm talking strictly about separating these two guys at the moment, without touching the API, what we could do, one thing we could do is basically duplicate the structs here that I'm highlighting in the document. We have 4 structs that are currently hosted under Cloud Init. We can create a duplicate of them inside the Ignition package and then use that for rendering the string. Now, why duplicate? Well, we don't have to. We could just take these types and maybe relocate them in an independent package that's not under Cloud Init, but that's going to be a little weird because these are Cloud Init specific fields for the most part, right? So if we put them in some independent package, then in terms of like the package structure, it's going to be drier code. We're not going to duplicate, but any provision or implementation, for example, Ignition, is going to have to rely on these types, which are flavored or like colored by Cloud Init in a way, because we don't want to touch the API, right? These types aren't part of the API, strictly speaking, but they are directly populated from CRD fields, right? So, for example, let me check one example. So the base user data type has fields such as write files, users, NTP, disk setup, which are all just plain old Cloud Init fields, you know? So I'm wondering which way it would make sense to go, duplicate or have an independent package. I think that if we do go with an independent package to save these copy-paste, the duplications, we should be very clear that any, as long as we're not touching the API, any Bootstrap provider implementation that is like flavored by a specific provisioner. So let's say an Ignition flavored CABPK would have to still basically support these fields and handle them because the user doesn't know. The user is going to populate these fields in a CRD and expect the underlying provisioning system to handle things correctly. So this is basically what right now the Ignition implementation does. It sort of tries to estimate and says, all right, if there is an NTP field, Ignition doesn't have an NTP field as far as I remember. But if from the Cloud Init type we have, if the NTP field is populated, then do something in the text template that we render. And by do something, I mean, we of course render text in Ignition. Maybe let me just show that because this is too theoretical. You know what? Just give one example. I cannot share screen because host disabled participant screen sharing. Someone give him permission. I guess that's you, Fabrizio.
I'll take a look.
That's Tylo now. The
Tilo, you have the permission now? Yeah.
You know how to do it. You have to do
I
on the guest
think
list.
Advanced sharing options. Who can
It's
share?
hard to find.
Yeah,
I didn't mean to
No,
put
yeah.
you on the spot, Tilo.
No, it's fine.
Could
That's
have-
fine. I'm
I thought it
learning.
would be simpler if we
I
all
like
see
this.
what you're talking about.
You can click on participants and then
Mhm.
click on somebody in the list on the right.
I
I do.
it should. Can you check if it works now?
It does, thank you.
Oh, good.
Now I need to find the window, which is also complicated. Use system window capture. What does that mean? I'm gonna try. I have no idea what it's gonna share. Is it sharing my IDE now?
Yeah.
Yeah, looks good.
Okay, is it legible, the size and everything?
Yep.
Wait for my.
Yeah, if I maximize it, it's good.
All right. Cool. So basically, this is, for example, the cloud init package this is under CABPK and then internal. This is not the global internal, which we also have, if I remember correctly. Yes. So this is the internal. So here, for example, let's look at the base user data. So these fields are populated by the kubeadm config controller. So for example, if we go here and we look for base user data, then here we're taking things from the CRD, right? Blah, blah, config, spec, NTP, for example, which the user populated, or this or that. Some of them are kubeadm related, but some of them are cloud init related. For example, that's not a kubeadm field, that's a cloud init field, right? And then we use these values here to generate the template, which is this internal function, which eventually gets called by the only exported function, which is somewhere, where is it now? Here, for example, new cloud.init.new init control plane. Oh yeah, it's a separate file. So that's the only public or exported function, if I remember correctly, that the package exports. Maybe there are actually 3 of those, I think, because we have like init control plane, join control plane, and then join worker node. But basically, let's take this one example. And the problem is that if we go to the equivalent, which is ignition, I'm just switching from the cloud init implementation to the ignition implementation. It's the same path, just ignition at the end. Then here we can immediately see that cloud init is imported, right? These 2 packages are interdependent. If I look at the types, then here in the node input, which I'm using here to render the stuff, I'm embedding this cloud init.node input field, right? So everything is dependent on cloud init, basically. There are almost no ignition specific fields. There is a little bit like here, for example, because we have like CLC snippets or whatever, which is ignition specific, but in general, everything here is based on cloud init. And then here we can see an example of, or you know what, let me show the cloud init template first. So here we should have, for example, things like files, which is a section of the cloud init config surface, and that gets used in where? Yeah, so we have like files and NTP and users and this setup, whatever, and then the whole template gets assembled, and then we're spitting out bytes, right? And then in Ignition, we have the same thing. It's just in a file called CLC. It is the big template, and then we populate, for example, we use the fields from the CRD in the end, like users, for example, or let me show you the NTP example. So if NTP exists and is enabled, then include this, which is basically an ignition workaround for the cloud init NTP feature, right? We're basically enabling a system unit on, for example, Flatcar. Yeah, so this is one thing. I think I can stop sharing now. I'm going back to the document. So yeah, any opinions on whether we want to copy the relevant structs, outsource them to a like independent package, and then consume them by both Ignition and Cloud Init, do something else that I haven't thought of? Yeah, feel free to chime in.
So I wonder how exposed those types are. Do they exist outside of core cluster API? Like, are they used by the vendor implementations as well?
That's a good question. I would ask myself if these are used by the infrastructure providers. I suspect I remember something around Ignition, maybe in CAP-A in AWS, the AWS provider. But in general, the main consumer that I know of, because anybody can consume that, it's a Go package. So as long as it's exported, people can use it. But as far as I know, the main consumer is the kubeadm config controller, right?
Are those type internal?
Depending on which types. So the 4 types that I highlighted here, no, they're exported because the way Go handles with like marshalling, unmarshalling, they have to be exported even if you're not using them.
Okay.
From the outside, you know.
Yeah. May I share, Tilo? I try to juggle down because when I'm thinking at this problem, I'm maybe I'm thinking from a different angle. I want just to share. So I try to make it simple.
Just regarding it being internal, isn't it in an internal package? Because then it's internal regardless whether the types are exported or not. And to me, it looks like it's bootstrap kubeadmin internal ignition and internal.
It
Good
is, so
points.
providers shouldn't be able to get to it, right?
Yes.
Well, I'm not sure how this is enforced in Go. Like, if there is the word internal somewhere in the path, then that's considered an internal package, because as far as I know, I mean, there is
Yes.
definitely a limitation if there is a top-level internal package, but you're saying here this is considered also internal?
It's the
Yeah.
same. So basically, if it's
Mm.
any package within the kubeadmin package is allowed to access anything in internal. But if you're one layer above the kubeadmin package, you can no longer access internal. So internal only is on the same layer or below, but not on higher layer.
Great point. Okay, let me write that down.
That is good news.
Okay. So when I think of this work, and to be honest, I didn't have too much time to invest on it, but there are a few things that comes to my mind. So the goal of this entire discussion was we want to reuse the logic that handles kubeadmin. Okay, if I think about the logic that handles kubeadmin, and I focus only on kapbk, not on KCP, but you can do the same reasoning about both. There is this kapbk controller. Okay, let's call it a reconcile. At the end, it is a reconcile function. But yeah, it is the kapbk reconciler. And this function does a lot of stuff. Okay, that I think we want to preserve. It does orchestration, which is probably the most important stuff that it does. So basically, it is the kapbk controller that decide when is the moment to create the init configuration for the first control plane node, when it is the moment to create the init configuration for the joint configuration for the secondary and the third control plane nodes. And it is kapbk that decide when it is the moment to create the configuration for joining workers. So it does orchestration of the entire cluster provisioning workflow. And this is something that we want to preserve. Then it does another big chunk of work that it does, it handles the kubeadmin token. And so every time a machine has to join, we create a token. And the kapbk controller makes sure that this token stay alive until the machine is actually joined. Because it could take longer when it is in bare metal, whatever. And it is even more complicated when you have machine pool, because you need to keep an always always existing token. And this is another important job that the kapbk controller does. And in the middle of orchestration, so it is a very small part in the middle of orchestration, we generate the data secret, and we have all the discussion, the code that Jonathan was explaining about continuity, initial, etc., etc. So when I think about this, I got the point that we were looking at, but my first concern is how do we reuse these? Because what I have in mind is that tomorrow there will be a kubeadmin-ish. So first of all, this controller today taking in input a kubeadmin config that has this weird mixture between kubeadmin types and initial types that we don't like. Okay. What I imagine tomorrow is that we will have a new CRD that I call kubeadmin config initial, name TBD. And there will be a new kapbk initial controller, reconciler. And this reconciler, it has to do, so we want this reconciler basically to inherit most of the goodness of the previous one. So we want only, basically, orchestration should be the same. Handle Kubernetes commit should be the same. The only things that we want to make pluggable is this generate data secret. Okay, so we can go here, we can drop all the Kubernetes types, we can have clean initial types. Everything else will work as it is. The only things that will work different is this one. Okay, this is what I have in mind. And so in my mind, I have this very naive and preliminary idea that the actual work that we should do is to keep this controller, this reconciler, transform in a controller that takes in input a type, a generic type, and somehow this generic type offer the methods that we want to plug in. So I don't know if it's like talking, oh, we have to solve a problem. How do we start? Bottom up or top down? Jonathan started bottom up. I have in mind the picture top down. Honestly, I don't know what will be the cleanest approach, but I think that if we sort out these, we will get to a point where we have to identify and clean up the code that Jonathan is looking at. And so maybe it's better to start here. But that's very naive and preliminary idea.
Doesn't even need to be generic. It can just be an interface, and we pass in the secret generator or something.
Definitely. The things that, let's say, is the easiest and the fastest to implement works to me. But yeah, I use a generic just to make the concept. This is the thing that we want to plug in, a new API.
Yeah, I think it's great that you provided this top-down view, Fabrizio. First of all, I haven't got yet, like I only talked about separating the two provision implementations. I haven't talked even about Bootstrap yet, but you definitely have a better view of the project than I do and more experience. So that's very good. You actually opened my mind to a new possibility that I haven't thought about, because on the left, you're proposing, I know that this is not a concrete proposal, but you're mentioning something like kubeadm config ignition. So introducing new types that aren't breaking the existing types, but are changing the API in the sense that now you have more options on the API. If we're introducing new types, which is fine because we're not breaking existing functionality, then maybe we don't have to inherit all the cloud init specific stuff in the ignition flavored Bootstrap controller, Bootstrap provider, right? What if it's an ignition flavored one? Maybe have native ignition fields in that type, right? And there is no problem with that because it is explicitly a separate type. Does that make sense?
Exactly.
Yeah.
It is specifically designed for ignition. You can basically start clean, forget all the mess that we have for cloud init. Up to you if you want to keep the same modeling for the cloud cluster configuration stuff that is more Kubernetes specific. But that's and ideally, when this type exists, what we can do is we can go there, we can deprecate the initial stuff from here, so we have two clean implementation. One is Kubernetes config cloud init. Unfortunately,
which doesn't
it's not
have
easy to...
Right, which doesn't have, it's implicitly cloud init because that's the default. It doesn't have cloud init in the name, right?
For historical reason, this is what it is. We can think to create a new CRD, deprecate the old one. Unfortunately, it's not so easy to change the CRD name in Kubernetes. But let me say, this will be okay. The initial point is that we need to enable this this new world to kick off and take its own path. And this will then enable to go back and clean up the tech debt, the debt that we have, which is the ultimate goal, let me say, from the core CAPI point of view.
Yeah, that sounds very good to me. I want to emphasize that everything you just described. So the only difference between this description, Fabrizio, and the scary design proposal that I initially proposed is that in addition to doing everything you just said, there is also a separation between kubeadm fields and provisioning fields. So imagine that we have now two types, kubeadm config for Cloud Init and then kubeadm config for Ignition. Then the differences will be that, the thing that's going to be identical is like kubeadm specific stuff, which both kubeadm specific fields, which both types are going to have. And then in the Cloud Init flavor, we'll have NTP and disk setup and whatever. And then in the Ignition flavor, we'll have things that are specific to Ignition. So all of that is the only extra step that my scary design proposal adds is, yes, but also let's separate, like imagine that we're putting a line in the middle of this CRD and separate the bootstrap related fields from the provisioning related fields. This is the only extra step. I'm not suggesting that we go in that direction again. I'm just highlighting that what you just described goes like 90% of the way that I suggested we go, which is great because I think it addresses a lot of the issues, not all of them, because in order to address all of them, you'll have to do non-backward compatible changes in the API. So,
yeah, but I agree.
I'm happy about that.
Let me say, I always wanted to get this CRD with a better, even keeping one CRD, we can definitely have a better separation of information. So when users look at it, it is easy for them to use it because it is clear what is what. Now it is a sort of a blog where folks keep adding. So definitely down the path, this CRD needs a redesign, and probably we'll get to have a better separation of concept like provisioning or Kubernetes provisioning, all that we discussed. What was important for me was to point out that there is a lot which is not provisioning and not Bootstrap that we want to share. And probably it is the biggest concern because this makes the difference between, in KCP, I don't know, it is 6,000 line of code, something like that. Sorry, in CapBK. If you look at KCP, where you will have this problem, it is 10 times the number of line of code and number of the 10 times the complexity. And what we really want to change is, what we really want is to have a nice API, etc., etc. So that's let me say that's the maybe the area that we have to research. How can we share basically a reconciler, making the kubelmin config the API type pluggable, sort of. That's
that's
an
good. I added that
problem.
I added that to the open questions list in the implementation document. Sorry, what's that?
I will grab this screenshot for this and add to your document. So
sure.
Or yeah, I can share this. Why not? It's just a Bootstrap. How you call it? This working group?
NOBO, Tila named it.
Nobo.
Nobo brainstorming. Save. Anyone with the link? viewer, and then if you want, I can make you editor as well. Okie dokie. That's what my just it is just a different angle.
Yeah, so that's good. That makes a lot of sense, because if we didn't do that, if we didn't make the bulk of the reconcile logic reusable, then what would happen is the moment we create a new repository for the ignition flavored CABPK, we would have to copy paste thousands of lines of code. And then we immediately start diverging, right? If there is a bug fix here, we don't get it there. So yeah, it's very good that you brought that up so early. I mean, you actually foresaw I haven't even got to thinking to thinking. I never even encountered this problem yet. I mean, we will surely hit it at some point, but it's good that we think about it in advance. That's good. What else? So we talked about ignition and cloud init. I'm talking about the packages now, and then let's see. I'm just reading what I wrote in terms of separating cloud init and ignition from kubeadm. Okay, so in terms of separating the two provisioners from the bootstrapper, as far as I can tell, we can already relocate the packages anywhere, because they're just imported by the controllers package under kubeadm and can be anywhere. So basically, right now, the controllers package of CABPK, it's importing two modules, two Go packages, the cloud init at the end and ignition at the end. And right now, these two packages happen to be close in the tree to the controllers package, but they don't have to be there. They could be even theoretically in a separate repository if you wanted. So like moving these pieces is easy. There shouldn't be too much like disentangling to do there, I think. And the relevant types, as far as I can tell, they're already exported, namely public, because of the marshalling and marshalling, I guess, or maybe there are other reasons, but I couldn't find more use cases. I wrote like we have an open question regarding whether CAP-A or other providers are using them, and have to move any types you want. Yes, and that's another. So moving out of the internal package is another, basically a to-do, I guess, that we have. Okay. I think that's a good start. Is there like more ground we can cover in this meeting? Should we like start allocating to-dos to people? What do you guys think? Are the major areas we haven't discussed at all regarding this workstream? No. Okay. Is anybody else besides me going to be available for implementation work in the upcoming weeks, at least until we meet again? I guess that's a no. So is it okay if I start? What's up?
I'll be around, and if there's anything that you think is separable, I'll be honest, I'm just trying to clear all my other tasks so I can be focused on this, and I'm almost there.
Mhm.
So, but I'm not taking extra vacation over the next couple of weeks. So definitely, if you want to ping me in our Teams channel or in Slack or whatever, and say, take a look at this, I'd love to.
Will do. Okay, that's good. So I'm going to be, I guess, driving the implementation work largely on my own now. And Matt, I'll coordinate with you and see if you have extra cycles to help. Is that okay?
Yeah, please.
And yeah, I'll post some updates somewhere when I guess I can do that on the Slack channel maybe periodically. But yeah, I think we already agreed that at least for now, I mean, we won't do all the low-level discussions on the CAPI channel, which it's a little too low level for that public channel. Right now, all the implementers happen to be Microsoft people, so we can discuss things internally. But if we need like a group on Slack or something because more people join, then of course that's great, and we can move the discussion there. So the moment a non-Microsoft joins the like actual coding, then let's move the discussion to a public platform.
I really wanted to. I really would prefer having this public.
Sure.
If he
That's good enough. Yeah, if anyone complains, then we're just going to stop using Teams.
It's not just that. Of course, it's the image part of the story, but should we progress to a certain point where we actually have something usable or proof of concept or whatever, we will have created a whole corpus of documentation, and then we need to move it, right? Because we want to make it public and not, I don't know. I'd like to prevent it from the beginning. So Slack is fine.
Fair enough.
Slack is fine. I can set up a new channel on Metrics, but probably not because Cluster API folks are on Slack. I don't know if the Cluster API channel is the right place or if you put it elsewhere. Happy to use the Flatcar channel. We have a Flatcar channel in the in the Kubernetes Slack and in the CNCF Slack. So there's ample room wherever you folks find it most reasonable.
We could just start threads in the CAPI channel, and if we get to be too chatty, then we can come up with another solution. But
That sounds great.
I'm fine with that.
probably it wouldn't be obnoxious, and that seems on topic there.
All right, yeah, that's good. By the way, Tila, all the docs are already Google Docs. I didn't create like internal Word documents or whatever. So
Okay.
yeah, they are shareable, but yeah, that like chat communication, maybe it makes sense that we can in retrospect expose it to more people who join later on. So yeah, sure. I don't think we have any like internal discussions so far almost at all around this work because so far I think I'm the only one who actually touched the code. So
No,
yeah,
we just discussed whether or not we should use Teams for this purpose, and we weren't really sure. So that's all. That's
Right.
the whole discussion so far.
yeah.
Tilo, if you want, I've pasted the link to the Contribex page for requesting Slack channel.
Yeah, we did that for the Flatcar channel once we went through the
Yeah, it
process.
should be just open. If you want, it should be just open an issue.
Yeah.
Somewhere.
Yeah, I mean, I think starting with a thread is a good idea, like Matt suggested, because I mean, so far it looks to me like this specific work stream is not huge, right? I mean, hopefully we can be done with that fairly quickly, I guess. I don't know. Maybe, I mean, I don't have a problem with opening a challenges for that. That's fine. Okay. Any other topics? Anything else we want to discuss? Or Tila, I think you started driving the meeting, so maybe you should
It's
conclude
fine.
it.
I'm absolutely fine with people doing my work. It's cool. Just lean back and enjoy. I see that Jacob actually brought in a discussion point from the original proposal.
Yeah, regarding my comment. I didn't see your message, unfortunately, on Slack, Jonan. But I think we are on the same page. So maybe to just summarize it quickly, I don't like, first of all, a question, because we're talking so much about splitting up the code now in the repository, which is like a solution for the problem. And we're also talking about introducing a new type to like cover ignition fields, which I don't like. I'm not sure whether it's intended as a temporary solution or like a permanent idea, because in my opinion, it just makes the entire situation much worse. Because we have even one more CRD that's then binding a bootstrapper like kubeadmin to a provisioner like ignition, which it's like the opposite of what we want to do. We want to split it up. Like in the picture that Fabrizio drew before, the last step, creating the cloud init configuration, in my mind, that's not the task of the bootstrapper if we talk our terms. The idea would be that we separate creating the provisioner specific configuration from the bootstrapper. So adding a new type for a combination of bootstrapper and provisioner feels very wrong from that perspective, at least. And separating the code, I mean, yeah, sure, why not? Makes it a little bit cleaner, but does it really help? Because the main, like we want to make the process of transforming or turning bootstrapper tasks, which is like provisioning Kubernetes on a node. We want to separate that. We want to make turning these tasks into provisioner configuration. We want to make that stuff reusable. And the way ClusterAPI usually does that is by introducing a contract and a provider concept, and then having a different providers that do it in different ways. So my proposal, and I think I'm not sure how much we've talked about this yet. I've tried to describe it in the comment, is to, well, introduce a new kind of provider. That's a provisioner provider or whatever we call it, a provisioning provider that then takes care of turning bootstrapper tasks, which need to be like presented in some format that's generic enough. And what I meant is for bootstrapping, it's probably sufficient to be able to create files and run commands, because that's what at least what kube admin is doing. And technically, you can do everything else with commands and files as well. Like there's not much you can do. It's just more user friendly to do it with config files, or with like a config file. Like creating a user using a command is much more tedious. So there should probably be a very simple interface, something that we can also find by introducing an interface that we use for what we've talked about just now, making the kube admin implementation more generic, and then allowing to plug in different generators that generate different kinds of provisioning configuration. That same interface could also work between providers by just writing it into a config map and having a different provider read the config map and then turn it into, for example, Cloud Init configuration. And then we can introduce CRDs that allow you to set the provisioner specific configuration in like a well-formatted way, completely separately from kube admin or whatever bootstrap provider you want to use. And that way we abstract it completely, and no bootstrap provider needs to have provisioner specific implementation anymore. I've drawn a picture. Maybe that helps as well. I can also, well, probably for sharing, I need permissions first, or I need to even restart.
Should have given permission to everyone.
Let me see. Probably need to restart Zoom. Privacy. Yeah, I'll be right back, I guess.
So I can say in the meantime, I mean, I want Jacob to hear that too, but I can say in the meantime that personally, I really like this approach. This direction is actually a part of what I suggested. Oh, here's Jacob again.
Yes.
So I started saying, sorry, are you done, or you wanted to say something else, Jacob?
I wanted to share my screen. That's was
yeah,
the
go
idea.
ahead.
To show this drawing quickly, maybe to make it a little bit more understand if I can find. I have too many screens. Which one? This should probably be it. Ignore the absurd amount of tabs. Yes, a very quick drawing. So as we know, machine sets create machines, and they also create, more or less at least, the infrastructure machine and the kube admin config for each individual machine. In the case of KCP, it's different, but this is easier to draw. And the idea is to just in between. So basically how it works is you create a kube admin config, and that generates a Cloud Init secret. And then the infra machine consumes this Cloud Init secret. And the idea is to insert a additional resource in between, like Cloud Init config, for example, that consumes the output of the kube admin config and then turns it into a Cloud Init secret. And then the infra machine consumes this Cloud Init secret. And then you can have Cloud Init config templates where you can specify your Cloud Init specific configuration stuff. And it works the same way as all of the providers do.
What will be responsible? Sorry, what will be responsible for the orchestration of the init workflow?
And that would still be the KCP. So this is for machine sets, which is very simple. But in the case of so the KCP needs, as it's able to also create from infra machine templates, it can already create infra machines. You can also use, or it can also from provisioner. So this is now a specific one, but from a Cloud Init configuration template or Cloud Init config template, it can create a Cloud Init config. It does it as well.
No, today it is this cap BK which is responsible for the provisioning workflow. But it basically it can do this because it is the one that generates the Cloud Init secrets. If we defer generating the Cloud Init secrets to something else, then we have to move the orchestration workflow into Cloud Init config, but the orchestration workflow is specific of kubeadmin.
Why? I don't.
So
I
the
don't.
orchestration, let's clarify, let me try to explain. So the orchestration today, the CAP-BK controller is the orchestration logic that I was explaining before. This orchestration logic is a logic that decide. It looks at all the machine that has to be generated and decide, oh, I pick one control plane machine and generate the cloud init secret for init control plane. And then when the control plane is up, it generates the init. It basically allow the next machine to go up, to go on and join as a secondary control plane. And same it does for worker. Okay, the way it does this, it basically hold on, creating cloud init for the different machines until it is the moment in the provisioning workflow. Okay, this is a responsibility of the CAP-BK controller today. It's not Bootstrap, it's orchestration. And it is the main goal. It is the main goal of CAP-BK, basically.
But shouldn't the control? So there's two controllers, right? There's the kubeadmin control plane controller that takes care of creating the control plane, and then there's the Bootstrap controller that takes, as far as I thought it worked that way, that the Bootstrap controller takes care of turning a kubeadmin config into a cloud init secret.
Yeah, but when it does this, it takes care of the orchestration.
Okay, but isn't the KCP, like the order in which control plane nodes are created, isn't that controlled by KCP?
No, because orchestration is a concern that goes across the entire cluster. It's not only a KCP concern.
Yeah, but okay, then I maybe misunderstood it. I thought so. The way I would think it works, maybe to explain that, maybe that it makes more sense that way.
No, but I got it. The fact is, if you look at these, we are missing another provider, which is the Bootstrap orchestration provider. And if you go down this path, basically to do what we do today with one machine, we one provider, we need three. And I don't think this is an improvement in terms of usability.
That's true. But then I just made wrong assumptions about where the code lives. Because from like a user perspective, it looks like Kapi behaves the following way. It creates a control plane. In this case, we use KCP, like probably most people. At least if you're not on a cloud using managed control planes. So you create a KCP, and then the job of the KCP is to create a control plane using the kubeadmin Bootstrap provider.
KCP creates a machine and its own kubeadmin config object and infra machine object. But then the machine is sort of stuck. It's just created. The next step is CAP-BK comes in and it decide, okay, this it doesn't look at the KCP, it look at all the machine. It decide, okay, this machine now can join or init, and so it created the cloud init. And then provisioning goes on for that machine. So KCP is only managing the replica of machines, but is not managing is not orchestrating the Bootstrap workflow.
Okay.
I know it's not because it is how it works. Sorry for the joke.
No, it's fine.
I think that the Bootstrap controller in ClusterAPI is probably the piece of code which is less understood, and probably it is due to the name. It seems that it only generates a cloud init secret. Okay, but the fact is that it generates there is a ton of logic that decide when it is the right moment to generate the secret. And this logic, it basically is responsible to orchestrate the kubeadmin init and join workflow. And then there is also the logic to keep the token, the kubeadmin token alive. So you call it Bootstrap, it surface only a secret, but behind the scene, it does much more work.
Mm-hmm. But okay, I mean, I get it. And there probably will be, if we try to change it, there probably will be issues, especially with that kubeadmin token. But to me, it feels like or at least I thought that the idea is that that the control plane providers take care, because you don't really need to orchestrate creating worker nodes in a cluster. Like the Bootstrap, the kubeadmin implementation also just, if you create a machine deployment and the control plane is ready, it just creates all of the machines at once immediately and doesn't
When the
orchestrate
control plane,
anything.
when the control plane is ready.
Yes, exactly. And I thought that the way it works
Eh,
is KCP starts creating machines, and it technically can create one machine with a kubeadmin config that only contains join configuration, creates init configuration, and then it waits for this machine to be done and for the API to be ready, and then it can create, that's also the way it behaves as far as I know, and then it creates two more machines, or as many as you configure, but usually two more machines with a different kubeadmin configuration that contains join instead of init, because it's the second two machines that exist.
yeah, but in the
As
middle,
soon as
in the middle,
Mhm.
there is a CapBK that does it works.
Okay, but
Uh,
why? But so then orchestration is split between the control plane and the Bootstrap provider, because
not really, because KCP just create a machine,
but it creates only one.
and then he waits for the machine to get ready,
Yes,
and
and
then
that's
the
already orchestration.
it waits. He orchestrate the control plane machines, the replica, the three replicas.
Mhm.
Okay, so he
Okay.
waits. What kicks, and then sorry, I leave the talk to the word to Jonathan, which is the. But when KCP waits, there are other controllers that they take on the job of provisioning the machine. The first one is CapBK, the booster provider that figure it out. Oh, it's good to go. Yes, I created the cloud init, and I keep alive the token, etc., etc. And then when the cloud init is ready, the infra provider take over and creates actually the machine and does the bootstrap and the provisioning, etc., etc. But KCP is just waiting. When the machine is up, uh, then KCP figure it out. Oh, this machine, the first machine is ready. I can create a new one.
Mhm.
That's the separation on concern so far. Jonathan?
Yeah, thanks. Jacob, just want to say, personally, I really like your line of thinking, because we've actually discussed it briefly in the past, and if you look in the design document that I pasted in the chat, I don't know if you had a chance to see that or to walk through that, but I think the initial idea that I had in that proposal is largely what you're suggesting, maybe not exactly, because I think maybe you went a little further ahead, but the basic idea is a complete separation of the bootstrap process from the provisioning process. The thing that I really like about that is that it makes CAPI extremely flexible in terms of combinations of bootstrap providers and provisioning providers. My design document actually proposes introducing a new type of provider, which is a provisioning provider, and then you have a provisioner contract. And then as long as you generate the blob of text in whatever format that you want and store it at the right place for the infrastructure provider, then this is fine. And the bootstrap provider doesn't need to know anything about provisioning and cloud init and ignition and all that. Like, that's really nice, in my opinion, because of the flexibility. The question to me is, I think the question is, do we want to go in that direction now? And so far, what I've heard from Fabrizio and also from other maintainers is the answer is no. for reasons that I think we can discuss. But like, I'm fairly certain that if we wanted to bring the project in that direction, we could. And I'm sure there are many low-level technical issues in addition to what Fabrizio just mentioned that we will have to address. So if we go in that direction, my bottom line is that's a major undertaking. The scope is way larger than what we're discussing right now. Again, personally, I like that. I think that should CAPI have been designed like that initially, it would have been much more flexible, I think, and much easier to maintain. But there is an existing user base. That's not the case right now. And then the question is, do we want to step in that direction? So personally, I would say maybe we shouldn't go too low level in discussing the issues with this specific proposal unless we decide that this is something we want to undertake either in this work group or in another work group. Not to diminish your work so far, Jacob, or anything like that. It's just that, like, even if you and Fabrizio right now got to an agreement regarding this specific point, I'm sure there is a bunch of other points that we'll have to cover before we have a chance of landing something which makes sense. Matt, your hand is up.
Yeah, I guess I'm just agreeing with you. I think what Jacob's talking about, we all probably feel is the right way to do it. And it may just not be possible at this point or not practical to go that far. And also in a previous discussion, I think we more or less agreed that supporting everything as pluggable really isn't necessarily a goal. It's not like people are going to go out there and mix and match and try out CloudInit and, oh, hey, I like Ignition better. I'm going to settle on this. It's more likely that, you already have a workflow in mind and we just need to support that. So it feels pretty painful, but I kind of want to push back against the correct, what I see as the correct design, breaking everything out, because it just seems like we'll never get there.
Yeah, if I can, I'm transparent. I don't have. When I face this problem, I also think of this solution, and then I realized that this ClusterAPI 2.0. So unfortunately, we did not start with this vision in mind. If we want to get there now, it will be a long and hard work. Think about not only getting this in place, think about everything which is around ClusterAPI. It will be impacted. Cluster class, you have to basically to reinvent cluster class. I don't know. Let me say the complexity. I see the cleanness of the model. I'm still not 100% that what we are doing is really beneficial for the users, because from the other side, every time we add a provider or even the existing provider, I just keep getting, cluster API is too complex to get it up and running. Why I cannot, why I don't have a binary to run, stuff like that. So I like pluggable. This is where this was, let me say, the key of success of Cluster API. But I just think that if we want something to happen, if we want to experiment, this is not the way to go. If we are designing ClusterAPI 2.0, let's talk about this.
Yeah, okay. I have 3 more thoughts about this and I'll shut up. So first, I don't think that introducing this, even with, I was just curious to learn about how the kube admin provider works. But I don't think that that's blocking introducing this concept, because the way it works right now, as far as I understand, is it just waits until it creates the cloud init secret. So instead of waiting to create the cloud init secret, it can also just wait to create what I have here, this bootstrap secret with some format. And that in turn makes the cloud init config reconciler wait until it creates the cloud init secret, and we have the same effect as we have right now. The second thought, now I forgot what I wanted to say. Yeah, maybe about introducing even more providers. I think, I'm not sure, but it feels like most people are probably not aware of until you start debugging stuff, but you don't have to deploy the kubeadmin provider because it's always packaged with cluster API, right? It always, like if you do cluster CTL init, it always installs the kubeadmin bootstrap providers and the control plane provider. And it could just as well also create or provision or deploy a cloud init provider the same way. And it's even possible to make creating or having this resource completely obsolete because you can always just default to creating a cloud init config with nothing in there, which would behave the same way. The main, and that's the third thing. The main problem with this here, or rather with this, is that we need to move, if we want this to be clean, we would need to move properties from the kubeadmin config to the cloud init config. And if we don't want to do that, we would need to do a lot of special handling for the kubeadmin config. And basically all of the bootstrap providers need to migrate to this eventually. But shifting the fields that are currently present in kubeadmin config and that aren't really necessary there, like creating users or I don't know what else, like creating files as well, technically is not really necessary. All of that would need to move to cloud init config. And that's the really difficult part because that's breaking API change. Everything else is probably fine and manageable, even with cluster class. But this, like moving the properties from here to here, that's the hard part. And that would be a very breaking API change or involve a lot of special handling of, like, if this references a machine that's using kubeadmin, then we fetch the fields from here and insert them here or something like that, which is terrible. That's my main problem with this approach. Everything else I think is okay-ish and should be manageable. That's the main problem.
Let me say, I'm not saying it's not doable and there are no solution. The problem is when we will get there. Again, my main worry is about users. You know, oh, I have to change my machine. And now you have basically you have two configuration, two files, two templates that you can rotate. They will become 3. Is that clear for user? Is that so clear for user, the difference between Bootstrap and provisioning? They only care about getting a Kubernetes node.
You will care if you do it with bare metal. That's where I'm coming from. We have a lot of issues mixing, like we have our kubeadmin bootstrap configuration contains more network config than it contains Kubernetes related configuration. It's like 60 or 70% routing agent configuration because we're running very complex network setup. I mean, that's just us.
I hear you. But at the end, you will have the same number of configuration, or you will have only split them into CRTs.
I think the user.
Is that a benefit or an advantage for the end user? You are an advanced user. I consider you a really advanced user.
No, but the users will care if they want. I think the user. Sorry for interjecting. I think the user will care if they want to support a provisioner bootstrapper combination, which isn't supported. And the reason it isn't supported was because for the maintainers it was unmaintainable because the project wasn't flexible, so you couldn't mix and match. So you needed, like, nobody bothered to create a new flavor of CABPK, for example, or somebody wanted K3S with ignition. I don't know, like some esoteric combination, and then it's not supported because it's very hard and a lot of effort to support new combinations. So in that case, yes, the users will care because they don't get the feature, you know?
Yeah, but I get it. So, okay, we gave the possibility of mix and match. Then what will happen? That the user will ask, oh, what are the combinations which are tested?
Sure, you can include a couple of curated templates in the repo, in the examples there, in the docs, whatever. That's fine.
But then you got back to the point that, yeah, in theory we support all combinations, but ultimately there will be 2, 3, 5, 4 combination that are the the one that the user most requires and the one that are most tested by the community.
Maybe I'm too
So
naive, but I'm wondering, like, if there is a proper contract for provisioners, and the end result is you take a blob of text and you put it in a secret. Do we really need? Well, I guess we do need to. I wanted to ask, do we really need to test all combinations, right? But
Yeah,
yes, the answer is yes, because maybe kubeadm won't be executed properly by the ignition blob that you emitted from the provisioner. So yes, I guess we definitely do need to test stuff. So that's a good point.
but I make you another example. Every all the Kubernetes version, there are some change in kubeadmin or in kubelet or in stuff like that that force us to change stuff in the kubeadmin config or KCP to make it work with the new Kubernetes version. So if you have kubeadmin and cloud init and kubeadmin and inition, yeah, I have two combination. I have two repositories that run end-to-end test. If you start breaking down and you have kubeadmin config from one side and cloud init from the other, who will be responsible, managed by one team, who will be responsible to test the combination? As a user, I cannot use them. Oh, I go to the initial team, they tell, oh, the initial provider is great. Yeah, but I need initial and something else. I need initial and kubeadmin. I need initial and Talos tested together. And it's not only an issue of develop them. It's also an issue to test to make sure. Oh, then I have initial 111 is compatible with which kubeadmin version is compatible or tested. So I got the idea of pluggability. But if I look at the backlog in ClusterAPI, so we don't have so much providers and so much combinations. And the only team that needed this flexibility is Ignition. So yeah, maybe it's a good design, but I just ask myself if you are over-engineering it. Just from it's cool, perfectly. We divide, have full separation of content, etc., etc. And then I go to my field engineer, and he tells me if I'm crazy because he has to create a new YAML and take care of it, and it has a new controller, and when it has an issue, it has to jump between three controllers just to get a file generated. So let me say, I'm not saying this is a bad idea. Probably this is a good and very clean design, but we have to strike so we have to strike balance between when we can do and okay, are we effectively doing some carrying benefits to the user, or we are surfacing a implementation detail because yeah, we want we want to reuse some code somewhere, or bare metal is hard because networking is complex because many other reasons. Are we solving the so yeah,
one of the
I stop
problems
on my
is,
rant, sorry.
yeah, no, it's all good. One of the problems with bare metal, at least right now, is how do you get your additional configuration that in other more integrated environments you don't need? How do you get that onto your machine? Like right now, Metal Cube, for example, one of the most prominent providers, they have an implementation that takes care of generating cloud init data. They support the IPAM contract to allocate IP addresses. They combine it, then they merge it with what they get from the Bootstrap provider, and then that gets executed. So they have implemented support for cloud init once again. And if you want to use Ignition with Metal Cube, that needs explicit support because otherwise you can't configure your network. We are working on a new provider that's geared towards Redfish and only supports Redfish and is a lot simpler than Metal Cubed. We also need to and we already did re-implement networking. We don't have IPAM support at that point because we're even more crazy, which is one of the nice things about pluggability, we have something on top of infra machines. So we create our own. So we have basically an additional resource here, which allows us to do stuff on a per machine level. So for each machine, we can react here, and then we create the infrastructure machine ourselves, so we can just inject everything directly, which is easier in our case. But that's also one of the reasons for that is because it's hard to get configuration in the machine somehow. So in our case, we allocate IP addresses here with our special shim machine, like the Docker shim, and then we add that network configuration to this infra machine, which takes an additional config map that also, so we basically do the same thing as Metal Cube. We also generate 2 cloud init configs and then we combine them into one. Or yeah, it works a little bit different.
I was
basically
chatting,
also have an option to create configuration here. But
I just answered to this because I discussed this with another contributor, which they are using shim machine like you. If we want to solve this problem, we can think about hooks that we apply when we create machines. I call you and I tell, oh, please do the changes that you want. Or another idea that I was discussing with this other contributor is we can have probably at cluster level some sort of configuration that apply to all the machine. And I don't know if this is the exact problem because we are talking very high, but what you are telling me, I'm not 100% sure, but I don't think that adding this split will solve your problem.
it can, because so what you could do with, if we have a cloud init config here, for example, what we could do is, and that it's again debatable, but this, for example, could support the IPAM contract, because if you create cloud init configuration, you might need IP addresses. So this would probably allow us. So this is not a problem. Like if we tried really, really hard, we could probably get rid of this, but it's working better than I expected. We didn't have any issues with it, as it allows us to do many things that we otherwise couldn't do, and it's perfectly fine. The problem is that this here, we need to, like this, all of these different kinds of bare metal infrastructure machines, if they don't have network automation, and for bare metal you usually don't, but even for like, I don't know, maybe something like Proxmox, or even for vSphere maybe in some cases, this needs to support injecting configuration into your operating system to configure it. And each of these different infrastructure providers needs to re-implement some way to get additional configuration into your operating system if you want to make things like, for example, network configuration part of your provider. Because otherwise, if you start to inject network configuration using the kubeadmin config, it gets terrible. Like the only way this works for us with Metal Cubed is because you can inject cloud init metadata using Metal Cubed, and then that gets combined with the configuration that's currently in the kubeadmin config and gets templated out by cloud init. That's the only reason that even works. And that only works with cloud init, of course. If anyone wanted to use Ignition with Metal Cubed, that would need to be re-engineered entirely. And then if Ignition doesn't support any templating, there's no way you can use it at all, because you can't do what we're doing with Cloud Init and Metal Cubed right now.
I need to bring this
Yeah.
to an early end because we're like 20 minutes over. I have
Oh,
one thought about this design, but I'm relatively ignorant to anything that happens above the operating system level. So I'm not very cluster API knowledgeable. But from like the enormous distance that I have, this kind of looks like as if we mix abstraction layers that shouldn't be mixed. Particularly, we are trying to pull the responsibilities that your basic cloud metadata environment has or environment provider has up to the Kubernetes level. And that from my perspective feels wrong, but I might be mistaken. Like most of the stuff that we're talking about here, and where we want to split or add abstraction to cluster API, is usually being served by your cloud provider environment or your bare metal bootstrapper environment. I know that Equinix Metal, for instance, does most of the stuff that you're talking about, complex network setup via an API that is either directly talking to the infrastructure or providing necessary information to the instances as in some form of cloud provider metadata. And from like, as I said, my huge distance, this looks like as if you're trying to pull that concern into Cluster API. And I don't know if that's a good idea. But as I said, don't listen to me. I really don't know what I'm talking about regarding Cluster API. But this is the impression that I got.
The thing is, I think I understand your point, Ilo. The thing is that Cluster API, in order to do its thing, needs to populate some values into the blob of text that gets served to the VM or bare metal server. So this is just a base requirement for CAPI to work.
Oh no, I
now
understand.
the thing is, Now wait, I'm not done. So now the thing is, if you're doing that, you have to do that in Cluster API because only Cluster API knows what it needs to generate for CABPK to fire kubeadm, for example. But then you also have like custom provisioning, whatever you want to do, network configuration, you want to do whatever. So theoretically, you could have the network configuration data come to the instance or to the bare metal server from a different source. But what happens often is that the existing mechanisms in CAPI get abused, which is another concern in the design proposal link that I put, that they get abused to convey generic provisioning, for example, network provisioning that unrelated, like you said, to Cluster API, simply because this is where you generate the blob of text that gets served to the machine.
And I guess because some parts of the functionality that you would need in the basic infrastructure aren't there, so you use what is there, you use Cluster API. And my point was, why not, try to provide the missing bits in the infrastructure instead of tunneling everything through Cluster API, which, doesn't really separate concerns cleanly. Fabrizio.
Yeah. I'm thinking back to Jacob concern. So I think that if I try to summarize, and sorry if I'm wrong because I'm kind of tired today. If I try to summarize Jacob's idea is, it is, Kubernetes config can become messy, very complicated, and this is what we want to avoid. So we already have the solution for this. So if you look at cluster class, you can create a cluster object. You can use a set of variables which are high level as you want. And then with cluster class, you can write JSON patch or actual code in Golang that generates for you the Kubernetes config and the infra machine as complex as you want, hiding all the complexity from the users. So taking a step back, Cluster API is a complex model, data model for many users. This is why we introduce a cluster class. And cluster class, it is why you have variable and you have patches, which are this way for enterprises, because developing a cluster class is not simple. It takes some, let me say, it has a learning curve. You have to get there. Developing a runtime extension is okay. But if you are an enterprise, you're managing many cluster, it is worth the effort because basically you shove all this complexity, you move it out away from YAML, you write in code, your code generates YAML and Kubernetes goes from that. So if I go back to the original problem, I think that it's not breaking, networking is complex, there are operative system or cloud provider that makes this a little bit simpler. If you are on bare metal, you have to you have basically to skin the onion layer by layer by yourself, and there is a lot of cry. But if we want to make this simpler for end user, there are already the tools. It's not introducing. I don't think that introducing another API make this better than write this in Golang code, which is an option that is already there. Yeah.
So I don't think that the problem is that it's a side effect. It's not nice, but that's not really the problem. That the kubeadmin config gets very big. We're unfortunately not using cluster class, but our own operator on top. Due to reasons, maybe we'll get to use.
And probably the issue with the shim machine, stuff like that, you are reinventing what cluster class is already doing. But maybe we have a chat separated and you.
Yeah. The main thing we're reinventing is the orchestration of upgrades. But that's a different discussion. My problem is that it's hard for providers, for basically any bare metal providers and also on-prem providers that don't have the infrastructure. And no, unfortunately, we don't have Equinix at home, right? So there is a lot of, I don't know how many there are, but in our case, we're there is some automation around our bare metal infrastructure, but it's limited, and there is no easy way. There is one point where you can inject your configuration into your OS image. There is no, I mean, of course you can build some custom solution that then downloads a script from somewhere if you have networking already, but you need to have networking in order to download something, and you don't have networking by default if you're not using DHCP, and we're not. It's terrible, by the way. Anyway, or at least for a non-network person, it's very terrible. So you need, ideally, when you insert so the way it works, you insert a small image that does provisioning for you. You boot a small image, a RAM disk, using a virtual disk drive, and then that starts, and then that downloads the actual OS image and provisions it to the system, because there is no cloud platform or VM that does it for you. You actually have to run some software or build an image that deploys your OS image and applies the cloud init configuration to the machine and all of that.
I was about to paste what Johannan did in the chat. There's a bare metal provisioning automation system that's called Tinkerbell, which is basically the Equinix metal infrastructure open source.
There's another one that's called Ironic. Tinkerbell is using PXE booting only, which we don't want to use because we hate DHCP. And Ironic is very complicated, which we don't want to use because it's not necessary if you have Redfish. So all of our, anyway, I won't go in. If you want to talk about it, we can, no problem. But we don't want to use Tinkerbell. That's why we started working on our own provider. But Tinkerbell, again, has the same problem, potentially, of applying, they also need to explicitly support Cloud Init. They will need to explicitly support Ignition. They will need to explicitly support anything else, because there's no other way there's no generic way of applying configuration.
That's true, but they do it at a separate abstraction level. They don't drag it into the Kubernetes level at all. They serve it on the infrastructure level. That was kind of what I was saying in the beginning. Anyways, folks, before Johannan falls asleep, he's standing in from Israel. He's actually a few hours ahead of us. I have a super easy win for you folks if you happen to be ClusterAPI maintainers. There's a PR which has an LGTM and all tests are green, and maybe
that's a shameless plug.
Yeah. All right, folks. Let's wrap this up real quick. Any last second mentions? Anything you want to bubble up? So good. All right. Enjoy the festival.
Have a great Christmas.
Sorry, go ahead.
Have a great Christmas.
Exactly. Enjoy the festival days and see you back on January 16th. Bye, folks.